It's a warm, lekker, hearty welcome to you, the listener and the viewer out there. My name is Willem and you tuned into another exciting technical edition of the Professional Plumber Podcast. Now, for the technical podcasts, I usually don't roll alone. I roll with Mr. Richard Baillie. Richard, warm welcome to you as well. And again, as usual, thanks a stack for your time and your effort in joining me.
Thanks, Willem. And as you say, as usual, it's been a lot of these sessions that we've done together, and it's always a pleasure, And we keep saying it, but it remains. It's always a pleasure to be allowed to share some knowledge and to impart some knowledge. Yeah,
isn't it? That's the purpose of these kind of technical podcasts and
Correct.
podcasts that we have is exactly that, to share knowledge and information with people. And to grow, develop, and uplift the plumbing industry.
Yeah, absolutely. And that's why there's always a commentary on what should be done and what shouldn't be done and how to do it, etc. But we try our best, and we keep plodding along, and we do our best, and hopefully it reaches a number of people.
Hey, we learn as we go.
Absolutely.
Richard, okay, so today we're talking about the mixing valve when it comes to stratification in heat pump systems. Now, I know that we've had a podcast and a technical discussion on the stratification in heat pump systems before, but today is we're sort of focusing on the mixing valve. Is that correct?
That's 100% right. So, Willem, one of the things that the reason I felt it was necessary to split or to do two podcasts on the same subject. It is the same subject. We're looking at it from a different angle. We're explaining it differently, but it is one of those things that is so often overlooked in a heat pump installation, and I don't think we can harp on it enough. I think, and you'll notice, well, what I plan to do for this podcast is to revisit a lot of the information that is already existing on the other podcast, because we need to put it into context. We need to first establish the need or establish why there is a need for what we are going to talk about before we can talk about the actual thing. So hence it might seem like repetition, but I think it's completely justified.
All right. Richard, so yes, we're going to do exactly that. We're going to quickly recap and explain to our listeners and our viewers out there what stratification in a heat pump system is. And then we're going to elaborate a little bit more on the other aspect of, specifically the mixing valve. But just before we do, for our viewers and our listeners out there, don't go away. Do stay tuned. We're going to hop into a quick ad break, but we will be back right now.
Are you having questions about the Plumbing Industry Registration Board and the plumbing industry in South Africa? Well, then join us on the couch and in conversation with the industry experts to answer all your lingering questions about the plumbing industry. The PIRB remains committed to ensuring open and consistent communication within the plumbing industry. So, be part of the conversation. Send us your questions on email at communications@pirb.co.za or on WhatsApp on 079 833 6930. Become a part of the conversation today. #on the couch. #PIRB.
Welcome back. You are still tuned into a lekker technical discussion of or on the Professional Plumber Podcast with myself, Willem and Richard Baillie. Today we are revisiting a subject that we've spoken about before, which is stratification in a heat pump system. But today we're sort of going to focus a little bit more on the mixing valve thereof. And Richard, as you were saying, let's just quickly recap and let our listeners and our viewers just remind them again about stratification in a heat pump system, what that is.
Yeah, so Willem, it's as I said a minute ago, it's one of the things that is so often overlooked. Let me rephrase that. The importance to maintain the stratification layers within a tank when talking about a heat pump system is something that is often overlooked, and the importance thereof is often overlooked when installing a heat pump, whether it's onto an existing geyser or it's a brand new installation. So stratification layers is a natural phenomenon that will occur in any storage tank where you've got, in our case, let's just keep it simple. We're talking about a hot water storage tank. So where you have a tank and the purpose or the objective of that tank is to extract hot water from it for use, you want to maintain what we call stratification layers. Those layers are essentially, they are layers, physical layers of different temperature water that stratifies and that kind of, it settles naturally within the tank. And left to its own devices, and if you measure the temperature at the top of a tank versus the bottom of the tank versus the middle and a couple of other spots, you'll find that these temperatures differ. And the heated water, which because of its heat energy, it's more excited. The molecules are more excited. They are further apart slightly from one another than cooler water. Therefore, it is less dense. Therefore, it is lighter in mass. And it will migrate to the top of a tank and displace the denser, cooler water to the bottom of the tank. So these stratification layers exist within any heated or hot water storage tank, and one needs to maintain them. If you don't maintain them and you mix it, so you've got what stratification wants to happen is hot water at the top, cooler water at the bottom. But if you mix that, then the whole tank is lukewarm. And if you open a hot tap expecting hot water, you don't get it. You got lukewarm, unusable water almost. So the stratification layers within the tank has to be maintained, and manufacturers go to great lengths of these tanks. Manufacturers go to great lengths to do just that when introducing new cold water. They do so at the bottom. They do so with diffusers to keep it kind of as a settled body of water that slowly rises up instead of a jet stream that comes and disrupts the thing. So great pains are taken to maintain these. And what happens with heat pump systems is that you introduce two additional, an inlet and an outlet to a geyser, and you start the circulation happening in a thing, and that tends to disrupt stratification layers in a heat pump system.
Richard, having touched on that, on having explained that the circulation part of it, and the warmer water at the top, and then the different layers and the different temperatures and different densities of water, for that matter, down towards the cooler water in the bottom. You explained about how the manufacturers of water heater storages go through great lengths in sort of maintaining those layers so that the right temperature water comes out at the correct outlet and those kind of things. You don't have. Let's go into a little bit more depth thereof of the actual process or the actual circulation for that matter.
So from a heat pump's perspective, your basic storage tank will have an inlet and an outlet, and you can reasonably successfully control the stratification layers if you're just letting new water in and displacing the hot water and taking hot water. So that's easy enough. But once you've introduced, as in a heat pump, you've introduced an input and an additional output, so you've now got 4 places where water either comes in or leaves at various times, and it starts to circulate. you now have a disruption of these layers quite easily. So a heat pump, the very nature of a thermo heat pump or an air source heat pump is to remove some water, cooler water from the geyser, put it within the system of the heat pump, heat it up slightly, and send it back to the geyser. Now, I just want to touch on a little bit as to how the heat pump heats the water. I'm talking about an air source thermo heat pump, which is the thing that we use here in this country mostly. The perception that a heat pump removes a little bit of cool water from the geyser, heats it up to temperature 60 degrees, and then puts it back is a misconception. What it in fact does is it heats it up by a couple of degrees, 2 or 3 or 4 degrees, depending on a number of factors, and the strength of the heat pump, and then sends that water back 2 or 3 degrees warmer than it was when it took it from the geyser. So the returning water from a heat pump, if it is allowed to return to the top of the tank, will cause lukewarm water at the top of the tank. It's not hot enough to be returned to the top of the tank, despite the fact that the port through which heat pump returns is usually 99 times out of 100 is at or near the top of the tank. Podcast, we touched on diffuser pipes, if you remember, Willem, and we spoke about the role of the diffuser pipe,
yes,
the fact that it is installed from that port near the top and transports that water to the bottom of the geyser where it belongs, and so that heating process can correctly take place. So if you just allow a heat pump to carry on with its own devices and you allow that water to be replaced back into the tank from the top of the tank, you're going to land up with a very, very dissatisfied customer, because as soon as I start using hot water for a shower, for example, the temperature differentiation probe senses that I'm now using hot water, that the lower temperature in the tank is sufficient for the heat pump to start to switch on. It then does so and immediately starts circulating and putting cooler, lukewarm water right close to the hot water outlet where I'm trying to draw my hot water off. So I have a shower, a minute later, the hot water has disappeared and I'm having lukewarm shower, and I don't know what's happening.
Exactly.
It's because the heat pump is switched on and it's returning the water into the incorrect position. So that's the net result when you don't look after stratification layers.
It's as if
now we spoke about
it's as if if it's not properly controlled, then it would seem as if the thing is not working, it's not functional at all, it's not serving its purpose.
Yeah, it would seem as though you're running out of hot water after using 10 liters of hot water. That's the experience from a homeowner's perspective, because that's the phone call you're going to get. You're going to say, listen, since you've put this heat pump in, I've only got 10 liters or 15 or 3 minutes of hot water, and then it's gone, it's finished. It's not the reality of the situation, because the heat and the heated water is still in the tank, but it's now mixed with the cold water. So now so the reality is different from the perception, but this is the perception. So one has to mitigate against that. Now, with a diffuser pipe method, which we discussed in a previous podcast, it's simple. It takes that lukewarm, semi-heated water and deposits it back into the geyser at a low level. So it's a very simple mechanical process. Now, the purpose or the subject of today's podcast is a different methodology of ensuring the stratification layers are maintained within a tank when you've got a heat pump attached to it. And we call it a mixing valve. Now, it's a pity I can't illustrate or show slides, because one needs to just imagine this in one's mind's eye, what this valve does. And one can go and look at installation diagrams to get a visual perception of it. But what it essentially does, and if I can explain it this way, it is a thermostatically controlled mixing valve. Now, thermostatically controlled valve means that water coming in from one side will exit one of two ways depending on its temperature. put simply. So this valve determines which way the water, once it's entered the valve, so let me start from the heat pump itself. It draws water from the geyser, cooler water, heats it by 2 or 3 or 4 degrees, puts it into this thermostatic mixing valve. The valve then can sense its temperature, decides which way it exits, and it exits one of 2 ways. The first way is if it's not yet to temperature, or if it's not hot enough, based on the settings of the valve, it will exit back into the circulatory mini circulation of the heat pump. So it exits and it goes straight back into the inlet of the heat pump. Heats up another 3 or 4 degrees. So now it was 25, it came into the valve at 29, and now it goes back into the heat pump at 29, comes back at 32, does another circuit, comes back at 35, does another circuit until it reaches, let's say, 45 or 48 degrees Celsius, goes back into the thermostatic mixing valve. The valve then sees, oh no, it's hot enough now, changes its mind and diverts it, and now allows it to travel back to the top of the geyser. So it's a valve that determines, in its simplest form, it determines where the water exits from it, whether it goes back into the heating cycle to heat it up another 3 or 4 degrees, or whether it's hot enough to now eventually be deposited at the top of the geyser, thus eliminating the cold shock effect or the lukewarm effect. And that, in a nutshell, Willem, is what a mixing valve on a heat pump system does. So whichever methodology you choose, and it's not for you to choose as the installer, it is for the manufacturer to tell you how to install the heat pump. If the heat pump is designed with a mixing valve, then you must install it with a mixing valve, or vice versa. You've got to choose one. I will say this. The advantage of a mixing valve is that you can see it's in place. You look at an installation, there it is. It's there. It's in the pipework. With a diffuser pipe, you never know.
Yeah.
So it's in the experience. And sometimes the diffuser pipe is short, and sometimes it's pointed upwards, and so it's touch and go at the best of times. But with a mixing valve, it's a simple, is it there or not? And then it's a simple, well, is it functional or not? So
Richard,
yeah.
I've got a couple of questions that I want to ask you about the mixing valve. Now, especially that we know what it does, its function, and how it functions. But I think just before I ask you the questions that I do have for you, for our viewers and our listeners out there, let's take a quick ad break. Please don't go away. We've got some more interesting news specifically regarding this mixing valve in a heat pump system, specifically for the stratifications, the stratification thereof. Do stay tuned. We'll be right back after the ad breaks.
It's that time of the year again during which we all deserve a break. As articulated, we'll take our break from the 9th of December to the 8th of January. We'll take this opportunity to thank everyone who uses our services and products. Here's to a happy holiday to you and your loved ones. Have a merry festive season and a very blessed new year. See you again on the 9th of January 2023. The PIRB Master Plumber Recognition Program has officially arrived. As an essential service to society, there must be constant growth and development within this important and ever-changing industry. Developed by the PIRB, the Master Plumber Recognition Program has launched as a new PIRB designation, allowing industry champions to take the lead. Skilled and experienced plumbers equipped to take the lead, enroll today to start your journey in becoming a recognized PIRB Master Plumber.
Welcome back. You're still tuned into a technical podcast of the Professional Plumber Podcast, or a technical episode of the Professional Plumber Podcast with myself, Willem and Richard Baillie. Now, in this specific episode, we have sort of revisited the subject of stratification in a heat pump system, what it is, how it works, and the different methods of how to control it, and the importance of how to control it. And just before we went into the ad break, Richard was discussing, besides the diffuser pipe, there is a different method, which is the mixing valve. And Richard, I found it extremely interesting because it just goes to show, how technology it just advances, it just evolves. I mean, bringing such an intelligent valve into a plumbing system and a heat pump system. I mean, heat pump itself is a piece of advanced technology within the plumbing industry. But then again, you speak of this valve and how it has this intelligence to determine, it's a thermostatic, you said, it's a thermostat that determines the heat and which way the water then gets exited from that. But still, it's an intelligent little thing, an intelligent gadget. So I want to ask you, Richard, we always refer back to the standards and that things have to be done according to at least minimum requirements of standards. Is there somewhere in the standards that speaks of this method? We've spoken about the diffuser valve or the diffuser pipe in a previous episode. Now we're talking about this mixing valve. Does it state where it should be placed, how high, how far, those kind of things? Are there requirements for it?
No. Yes and no, but essentially no, Willem. The requirement is that you stick to what the manufacturer tells you to do.
Okay.
So one must understand and remember that that the heat pump installation standard, for example, will say to you as an overriding statement that whichever heat pump you choose to install must be an approved type. Mm-hmm. Okay, which means that it has been tested and approved for use within the South African plumbing environment. And that it is the performance thereof has been tested and approved. So whichever methodology it chooses to use has been tested and it's fine. So however the manufacturer tells you to install that mixing valve, wherever they tell you to install it, whether it's within a certain proximity of the heat pump, etc., that is how you should do it. So yes, there are requirements, but those requirements lie with the manufacturer. They don't reside in the standards. The standards are broader than that. They'll just say to you, make sure you comply with what the manufacturers need.
Mm-hmm. Richard, but then...
Willem, I also just wanted to touch very quickly. You mentioned that the valve itself is quite an intelligent thing. It is. Although it's 100% mechanical, there's no kind of electronics or anything like that. It's mechanical and it works on a wax ball. And the wax ball has got a certain... I don't know the correct terminology, but it's got a certain expansion and contraction coefficient with regards to temperature, and it then acts on different parts of the valve and closes and opens portions of the valve accordingly. So it's a 100% mechanical thing, but it's a wonderfully accurate situation as well. It really does work fantastically well.
Yeah, I mean, I find it interesting when the water is not warm enough, if it's not sufficiently warm enough or hot enough, then it gets circulated back or it gets outlet on the one side of that valve, goes back into circulation into the heat pump to get heated to the correct temperature. And when it does reach that correct temperature, it obviously gets pumped out the other way, go back into the storage itself.
Yeah.
Richard, it's absolutely, the thing is, I always say when we have these technical podcasts that the average consumer out there do not know how these things work. And, that's where it comes in for plumbers to know and understand that they are the experts. They are the people with the knowledge. And they are supposed to not only install these things correctly, to be optimally functional and fully functional the way that it should be so that the user and the consumer gets what they expect to get from it, but also to inform the consumer. It's always that part of, teach your customers, because that's also one way of building rapport with your customer and building trust with your customer. If you explain to them how these things work. I mean, I sit here, I'm not a plumber. And I learn from these technical podcasts and the information that you share. And as a consumer, if a plumber shared that kind of information with me, I would have appreciated it a lot because I find it extremely interesting.
And also, if you make a connection between the technology and the physical workings of the system and your experience on the ground as a consumer, if you can make that connection, So the consumer can say, oh, is it that when that happens? Is that how that? And that connection is made, and all of a sudden it's a lot clearer, and one can then understand the need or the importance of getting stuff right. It's not just getting it right; it's why do we need to get it right.
And that's also how you justify what you charge for and those kind of things, is because now you clearly explain it in layman's terms, to the consumer.
Yeah, 100% right.
Richard, but again, as always, that these podcasts that we have, these technical chats that we have, maybe things that people have learned before when they did a heat pump course. I mean, there is a heat pump course on IOPS's e-learning platform, and it's good for them to sort of listen to podcasts like these, maybe take that course. On the one side, it's also to sort of not expand their knowledge or revisit knowledge that they may have had before, but also to sort of expand their business opportunities and the kind of services that they deliver to customers, that's expanding, growing their businesses.
100%. Couldn't agree more. It's like anything in life. The day I stop learning, it will be the day I die. So you learn every single day. And the more you know, the more you realize you know nothing. So that's the nature of the beast. But it's always a good thing, yeah. It's always a good thing.
Absolutely. Richard, once again, thank you for having joined me for this podcast, for the information that you've shared. I do believe that it carries the same kind of value to our listeners and our viewers out there as what it does for me. And then, of course, to our listeners and our viewers, please don't go away. We have drawn to a close of this episode, but we're not done with you quite yet. Right after the break, we will bring you some interesting industry news or industry announcements.
As of next week, Monday, the PIRB will be short-staffed. So be sure to contact us for urgent services before the end of this week. The PIRB's offices will be officially closed between Christmas and New Year. But we will be open again from the 3rd of January. But for now, have a lekker festive season. If you're interested in supporting charity this year, become one of the sponsors for the 2023 Champions for Charity event. Visit www.championsforcharity.co.za to find out more. Thanks to you, the South African plumber who not only wants to continually grow and develop, but who also strives to be seen as a true plumbing professional. We are proud to announce a change in the PIRB's CPD policy to show appreciation to those who continue to contribute to the upliftment of the industry. The PIRB is introducing the PIRB CPD Reward Scheme. Stay tuned for more information to come.